All right, so for today, we are talking about the basic 20 that we just finished up. And here's why we did the basic 20. Because you're going to have to graph things like this today, except much more intense than just this. But if you had no idea how to graph this, you would have noticed that on the basic 20. Because there was a graphing one, and there was also a find a function like f of 3. What in the world does it mean to say f of 3? That means stick 3 in the function. Well, where are you going to put it in the function? There's two spots. There's the x and the y. Well, you guys know it's f of x, right? So if I replace the x with a 3, then didn't I just say that x was 3? All right, so go ahead and see what you get when you do f of 3. This will require you actually sticking that into the function and doing a little bit of math in your head. And there's no calculators for your first several tests. So things like 3 times 2, you know, it's, if you can't do that, then you're in the wrong math class. Or you need to just fix it. You can fix it. Just practice it. 3 times 2 is 6, plus 4 is 10. And I just want to write exactly what I had here. Y equals, and I don't have to show all the work for this because I can do that in my head. 2 times 3 is 6, plus 4 is 10. Y equals 10. Well, of course, this was saying x equaled 3. And if I put them together, it's 3 comma 10. Does that make sense to you? X is 3, y is 10. That's the point, right? If I get enough points, I can put them on a graph. So there's 3 ways you can do math. One way, equations like this. I gave you that equation on the test. We mostly give you equations. Then you have to make points like we just did. Like that's a point that's on this graph. And then if you get enough points on an XY chart, you can then graph those points. So 310 was one of our points. And then you could graph it. If you go over 3 and up 10, put a dot. There, I made a point. If I make enough points, it's no big deal. I can graph it, right? Now I can tell from looking at this that this would have a slope of 2 and a y-intercept of 4. That means it would have gone through like here, and there's my line. Now, I actually find it kind of hard to graph on my iPad, and that's why I made a worksheet, like a physical paper worksheet for graphing today. So you can have a paper worksheet to do some practice on this. But I want to kind of show you where we're headed. Here is a typical problem on tonight's homework. Y equals 5x minus 7, and they want you to graph it and tell the domain and range of it. Now, I know domain and range is something you haven't done in forever, but when I did the practice test, I always try to do the test at the beginning of the unit so I kind of know what I'm getting you ready for. So I looked at your first test. And your first test it's not like next week. It's, you know, you're going to have a couple weeks and you're going to have this test. I made so many XY charts on that test. Is just over and over and over again. Like, and so you can't skip that part. Like, there's no way I could have done this test without making XY charts. So that's the first skill I want to make sure you get. And then we'll talk about domain and range in a second. So what number did you pick for X? Well, your numbers, you can pick anything you want, but you're going to have to graph them. So picking like 30 would be stupid because you'd have to graph 30, which is ridiculous. So pick easy numbers like 0, 1. Do you have to pick any negatives? No, you just have to have enough points. And sometimes the negatives are handy. So let's I'll force you on this case to do -1 and 0 and 1. Put those in and see what you get. This will be a point. This will be a point, and this will be a point. Once we figure out the 3 green question marks. All right, now this part is critical. I can't be the only person you check with when you are stuck. And just to see if you're doing it right, I'm going to constantly have you checking with the people across from you. And I'm willing to bet that you've probably already forgotten the person's name. And that's okay. You'll remember it after you've said it a couple times. And maybe you remember, that's awesome. But just because I don't want anybody to be like, oh, I don't want to be embarrassed that I don't remember their name, I'm going to ask you again today to say your first name and then see if you can remember their thing. I bet that sticks better than their name. because you probably visualized them doing it. Like, oh, you're a basketball player. I can picture you playing basketball. All right, so these 2 rows, you're going to be talking to the people across from you again and reminding them, just say it like, I'm Sophie, so that they don't have to ask you, okay? And then tell them, actually, see if you can tell them their thing. See if you can remember their thing, okay? It's you two, you 3, and maybe you never did before. And you're going to, actually, we're going to do this. We're going to go diagonal, and then you're going to talk about maybe you didn't know that before. All right, and these 2 rows is super easy because everybody's here. So straight across from you, and these 2, it's going to be you 2, and you are a group of 3. Okay, reintroduce yourself. Okay, Alex, who's that kid behind you? Rissy. Awesome. Do you remember, did she tell you a thing that she's into? All right, tell him something. Hanging out with friends. Okay, cool. And that is very true of most kids your age, so that makes total sense. All right. I would love for you guys to put -1 in this, and I always put it in parentheses. So it's 5 parentheses -1 minus 7. You got to be able to do this stuff in your head. That's -5 minus 7. That's -12. Raise your hand if you had -12. Okay, good. You're on the right track then. Do you get if you graph these 3 points? They are going to be in a straight line. And that will have a slope of 5. That's how steep the line is. And if you compare those dots, like you compare this dot to this dot, you would rise 5 and then run 1 to get there. So they wouldn't look like that. They'd look more like this. Be pretty steep. All right. The 3 forms of math: equations, data, or points, and the graph. Can you do all 3? I hope you can. Okay, because that's going to be the major thing for today is graphing these things, and then we're going to get to things that curve. So you've seen these before, like a parabola. Would you agree this parabola has been moved up a little bit from home base? Okay, it's been probably moved up. Let's say it's been moved up 1. Then it'd be y equals x squared plus 1. So I need to remind you of all those little moves. What if I had moved it down? Well, then it would have been y equals x squared minus, let's say I moved it down 4. It would look like that. That's down. So up is plus and down is minus. That's pretty easy. But when it's in a parenthesis, it's like this. That didn't move up or down. It moved left or right. And which one is it? Do you remember? This would be right 7. So I need you to take notes on this so you'll remember it. So I'm going to give you one that's got both. This is typical of your test. And you'd be asked to tell what happened to this function. And you'd be able to say, oh, moved right. So go ahead and write this one down. Copy this one down and then write right 7 and up 5. And I think you get, if they had the opposite sign, then they'd be going the opposite direction. So instead of right 7, it'd be left 7. Or instead of plus 5, it was minus 5, then it'd be going down 5. All right. But it gets more complicated, which is why I'm asking you to write. And I know some of you were like, I can remember that in my head. That's cool, but it's going to get more complicated, so copy it down. What if there's a 2 out in front? And then what if there's a negative on that 2 that's out in front? Now all of a sudden there's 4 changes to this graph. All right, so I'm going to ask you to copy this down, and I'm going to be walking around in a minute so I can see it on your paper. You know why I'm such a big, poo about making you write it down? Because it engages a different part of your brain. You can sit there, hear me, see it, and still not remember it, but if you write it, a different part of your brain has to engage, and that part of your brain is better at memory. It's not because I think you're going to look back at these notes. I get you might never look back at these notes. But by making you actually physically write it, a different part of your brain lights up, and that part of your brain's better at memory. So half of the secret of writing notes is not that you're going to look back at them. It's that it engages a different part of your brain. All right, so I'm going to ask you to show me this in a minute. And this one is a vertical stretch. And this one is a vertical, does anybody remember? It's a flip, but do you know that a word for it? All right, you're going to have to write this on the test. Every one of you is going to write the word reflection on the test, unless you're going to get it wrong. Vertical reflection, vertical stretch. So if I had to sketch how this thing would look, I would know that it was a parabola because it has a squared in it. And here's your standard parabola. Looks kind of like that. But that one hasn't been moved at all. And then I got to move it right 7, up 5, vertical stretch at 2, and a vertical reflection. Some teachers teach this where you should memorize these 5 points and then do all of those things to that. I think that's incredibly painful. I think that would make me take forever to get my homework done if I had to take all of those points then and move them up 5 and move them all to the right 7 and then try to figure out what the heck vertical stretching it to would do to it. I mean, I think that's really hard. So personally, I just like the XY chart. And I'm going to show you how we can find a point on this. Super easy. By just picking a number. But remember how I said a second ago you pick any number you want? And I said usually pick numbers that are small. In this case, picking a small number for these would kind of screw you over. Let me explain why. Because if I put a 1 in here, all of a sudden I have 1 minus 7 is still a pretty big number. That's 6. And then I'm going to square it. And then that's 36. And then I'm going to times it by 2. And it's going to be like 72. And then it's negative 72. And then I have to add 5. That gets really hard in your head. So do you get just sticking in 1, 2, and 3? That would have been like last year. Here in pre-calc, you have to be a little bit smarter. So instead of just sticking in things like 1, 2, and 3, you look at this, what you do to start with right here. You look right here and you go, okay, what would be a smart number to put in there? Hint, not 1, not 2. You get to pick anything you want. What would be smart? Come on. Like 7 or 8 or 6. Exactly. So write 6, 7, and 8 over here. You know why? Because they're all going to get really close, really small numbers, basically. Really close to 0. Do you get why? Because the first thing you're going to do is subtract 7 from it. So when you stick in 6 right here, now you got 6 minus 7, and you got to be able to do these in your head. This has to be second nature. This is what we're starting with in higher algebra today. I know you're not taking higher algebra. You're taking pre-calc. My point is, I know you did this last year. But I also know it was at the very beginning of the year. You did a lot of like doing this stuff in order. So I got to go 6 minus 7, negative 1. Negative 1 squared. What is negative 1 squared? Come on, this is negative 1, and then you square it. What's negative 1 squared? 1. And then you times it by, why do you times it? Because of the order of operations. Again, you did that last year. So now I'm up to 1. And I got to times it by negative 2. So what is 1 times negative 2?
Negative 2.
Negative 2. And then you add 5. What is negative 2 plus 5? 3. How many of you had a 3 there? Good. If you weren't able to do that, you will not pass this next test. Not saying if you can't do it right now. I'm saying on the test, you're going to be doing that over and over and over and over and over. Because to graph these functions, you have to stick numbers in, see what you get. Stick another number in, see what you get. So let's get good at that. Everybody put in 6 and then put in 7. That one works out really nice because this part becomes 0. And then stick in 8. It's okay if you end up getting 2 of the same numbers for y's. I won't be surprised by that. And I'd like you to just compare these 3 numbers that you got to the kid next to you. What did you get for 6, 7, and 8? All right, seems like a lot of you have done already. That's awesome. If I stick in 7, I'll show you how I walk through that. 7 minus 7 is 0. 0 squared is 0. 0 times anything is 0. Plus 5 is 5. 7, 5. Raise your hand if you had that one right. All right, there's hope for you. Then if I put in an 8, I end up getting a 1, which is a lot like a negative 1, because when you square it, you know, you still get 1. And then it's times negative 2 makes negative 2. Plus 5 is 3 again. And again, it's okay if you get the same number there. And then do you get, I've got all 3 forms of this. I got the equation, which they usually give you. I've got a list of points, and then as long as you know how to graph, and by the way, there's usually a kid who still struggles with which one is first. X's go here, Y's go here, and you always do this. This number is how far over you go. So if you need a little help with that, it's over then up. And of course, if it's negative, it's down. All right. So 6, 3 is like there. 7, 5 is like there. 8, 3. Wait a minute. 6, 3, 7, 5, 8, 3. What the heck is happening? How could that happen? Well, could it be that this is a parabola that is upside down and moved right and up? So that feels like those lines aren't lined up. Well, they're not, because it's a curve. See what I mean? It's a parabola that got moved over and up, and it was flipped upside down, and it was stretched. All right, so let's do another one. This is typical test question, like a long time from now. Y equals 9x minus 7. You got to be strategic about which points you pick. In this case, is putting in 0 and 1 and 2 going to be pretty good? Yeah, they're fine, because they come out with answers that are pretty easy to calculate, and they're kind of small answers. Garrett, what'd you get when you put in 0? You are correct, sir. Everybody put in 1. Ryan, what'd you get? There you go. 9 minus 7. 2 is correct. 1 comma 2. All right. And Anna, what'd you get for putting in 2? 18 minus 7 is 11. Very nice. Do you get if I graph those 3? It'd make a straight line. How can I tell it's straight? Because there's no squared. If there was a squared, it'd be a parabola, curvy. Okay? So if it's straight, it's called linear. So we just graphed linear equations. Feel like you could handle it? Right, now let's talk domain and range. So let's look at a typical normal-ish graph that goes like that. This is 2 of the representations. This one looks like it has a slope of 1 to me, and it looks like it has a y-intercept of 1. Do you get how I could take that equation from that graph? Because it looks like it's got a y-intercept, that's this thing, at 1. And it looked like its slope was going up 1 over 1, up 1 over 1. So then I put a 1 here. See, that's 2 of the 3 representations. What's the third kind? A list of points on an X and Y chart. Just to make sure you get that, everybody please make me a list of 3 points that are on the XY chart. This lesson won't be that much longer. Stay with me. Stay engaged. If you stay engaged, you will understand it, and then your homework won't be that bad. Everything is better. If you start drifting, everything gets worse. You miss something. Then you don't get it on your homework. Then it takes you longer on your homework. All right. try to be engaging. It's been 20 minutes already of the lesson. That means I only have probably 10 more minutes of your attention. So I'm going to try my best to get her done by then. All right. I know that easy numbers like 1 would work great here because I tried it and it comes out really easy. 1 gives me 1 times 1 is 1 plus 1 is 2. And then 2 goes in here. 2 plus 1 is 3. And then I put in a 3. And 3 plus 1 is 4. Does that make sense to you guys? Do you get how there's 3 ways to do math? One's with equations, one's with graphs, and one's with data or charts. Okay, cool. Now, what is the domain and the range of this? I know you learned it before. I would guess there is 0 kids in here who would define it for me. Some of you might be able to give me the answer, though. If I just say, what's the domain and what's the range? There's research that says that making you try to remember this will increase your retention when I tell you. So try to remember, what's the domain of this graph? What's the range of this graph? Think for a second. Okay. Did anybody remember that the domain was about the x's and the range was about the y's? Did anybody have that still connected in your head? I'm seeing a few nods. Okay, awesome. The domain is how far left to right the graph goes. If I extended this graph, because it's got arrows on the ends, right? Wouldn't it go forever to the left? Wouldn't it go forever to the right? I mean, it's still kind of going to the right, isn't it? I mean, I know it's also going up, but it's going to the right. And this is going to the left. So if my answer for domain is how far it goes from left to right, you would say negative infinity to positive infinity. Now, if you have trouble making infinities, like some kids do, I'm totally fine with you saying inf. You can say negative inf, comma inf. And you put it in parentheses like this. That's from negative infinity to positive infinity. Parentheses go around things that you're not touching. Let's talk about that for a second. If I had a number line and this was like 7 and it's empty versus I had a number line like then it was filled in at 7, do you remember the difference between those two is this one, the 7's not included, and on this one, the 7 is included. You see the difference? Filled in means 7 counts. Like 7 is included in the answers. This one, 7's not included. So this is like x is greater than 7. This is like x is greater than or equal to 7. See, because it can be 7. This one, it can't be 7. All right, so for the range of this thing, if I put a bracket on it, it means that it's like a filled-in circle. But in this case, it's really unnecessary because I just have parentheses again, and the range is from how low. I'm going to write it out for you so you might remember to how high it is. How low to how high. And that is from negative infinity to positive infinity again. Because the lowest that this graph would go, it would go infinitely low. And the highest this graph would go, if I extend it out, would be infinitely high. So the domain and range of this thing were negative infinity to positive infinity, both of them. All right, so is every answer negative infinity to positive infinity? Of course not. So I'm going to make you one more. Everybody graph this upside down parabola. Just sketch it quick like that. Write D for domain and R. The domain is how far it goes from left to right. The range is how far it goes from down, from low to up or high. Domain is left, right. And you got to ask yourself, if I extended this thing, if I just kept going the way it's going, how far left and right would this graph go? That's your domain. And the range is how far up and down it would go. All right, again, I'd love for you to take a second and really think this through. Give your best guess. And I know some of you are going to have to turn to your partner and say, yeah, I don't get this at all. Not yet. Maybe you don't get it yet. But this is something you did learn in higher algebra. I think at least half of you have probably got it back now. So if both of you are stuck, I'll show you the answer in a second. All right? See what your partner thinks about domain and range. Take a second. Talk. All right. Domain's left, right. How far does this thing go to the left? Negative infinity. If you get confused on where the infinities are, I'm going to put them on this graph. Maybe you should, if you get confused about which ones are where. Does that help? If some of you were like, what is this negative infinity thing? Well, it's because it's forever this way. That's negative infinity. Forever this way is positive infinity. Forever that way is positive infinity. And forever that way is negative infinity. Okay, so this one goes from negative infinity to positive infinity, and I'm going to make the sideways 8 for that second infinity. Because this thing goes forever left and forever right. It'll keep going forever in both of those directions. And if you're like, but it's actually going down. Yeah, you can be going down and to the left at the same time. How low does it go? Say it if you know it. Negative infinity, also known as forever. Very good. And how high does it go? Ooh, the first time it wasn't an infinity. 0, exactly. Now, do we have a bracket or a parenthesis? So, the bracket means it touches. Does this touch 0? Then it's a bracket. So when do you use the bracket? If it touches. Can you touch infinity? No, you can't like get there. Like, oh, I'm finally at infinity. No, you're never there. So you don't touch it. So it's parentheses on infinities. Brackets, that means you touch there. Okay, cool. I've taught you everything you need to know for today. I'm not saying you're the master of it, but now this is just the part where I'm going to try to make sure you got it. There's nothing new. Okay, so here's a typical question. Actually, you know what? Let's just do the first problem of the homework together, and that'll be a good practice, and it's getting your homework done. It feels a little long, so I will cut out a couple of problems off of this. I'm going to pause for a second while I hand these out. Okay, so here is your first question, number 1. It says the parent function, basically the function we're going to start with, is y equals 2x minus 4. And they just want you to graph it, and underneath that it says domain and range. So, well, let's not worry about the domain and range till we graphed it. But you know what you should have on every single problem? An XY chart, absolutely. I would put it to the right of your graph. You know your graph is here. Make an XY chart. I'm telling you, on the first few, you might be able to just do it in your head and go, oh, y-intercept is 4, slope is 2. You could do that. But on the harder problems, there's no way in heck you can do that. You're going to have an XY chart. So let's just get used to it right off the bat. So what's some good numbers to put in? Well, how about 0 and 1 and 2? Because they work nice. All right. Everybody take a second and figure out what you get when you put in 0, when you put in 1, and when you put in 2. If x is 0, then I've got 2 times 0 is 0, minus 4 is negative 4. Put in a 1, I got 2 minus 4, negative 2. When I put in a 2, I have 4 minus 4 is 0. Cool. Then can you graph? 0, negative 4. 1, negative 2. 2, 0. They appear to be lining up in a straight line, aka they are linear. Does that make sense? I think that makes sense. All right, good. So, there. Did my first one. Now I got to figure out this domain and range. If you have to, write X and Y next to them. You don't have to, but like if you need that, cool. X was go from left to right. How far does it go from left to right? Negative infinity to infinity. And the range is how low to how high. A very common mistake is to switch that around and put like how, from high to low. You will get it marked wrong. I have to. Math is picky. The range has to go from this. Here's another way to say it. When you're in those parentheses, the numbers have to be in order from small to big. Every single time from now to the end of my class. If you're ever in parentheses like that, you put the small number first, period. If you ever look back at your answer and it's like, wait a minute, I don't have the small number first, it's going to be wrong. Small number has to be first, okay? So from the range is from low to high. The small number, negative infinity. High number, infinity. There we go. First one's done. All right, let's look at underneath that one. I don't even know how to say it because they didn't really label it well. The problem is y equals x minus 4 to the third. Remember how I said you're always going to have an XY chart? And it's the number one thing I did on the test. Over and over and over, I had to make XY charts. Over and over. Like I probably made 12 XY charts when I was doing your test. Okay, so strategery. 0 is not a good number. Think about it. You're going to end up having to do negative 4 to the third power, and it's huge. So 0 isn't a smart choice. You might have started with that and then went, wait a minute, that sucks. So what would be a smart choice? 4. And even 6 might get a little bit big. So 4 and 5 I can buy, but how about maybe 3? And if I was doing it, I'd put them in order, 3, 4, and 5. Like 4 was a very logical choice because it makes the starting answer 0, and of course that's easy. But then you probably want to go 1 on either side of that. I mean, 6 wouldn't have been wrong. It just gets kind of big. All right, and again, I'll do all 4 of them just to show you that's not that hard. So if I put in 4, I get 4 minus 4 is 0. 0 to the third is still 0. If I put in a 5, 5 minus 4 is 1. 1 to the third is 1. If I put in a 6, 6 minus 4 is 2. 2 to the third, okay, 2 times 2 times 2, 8. It actually didn't get that big. But 3 would have been a little easier. I put in a 3 here. 3 minus 4 is negative 1. Negative 1 to the third is negative 1. Because negative 1 times negative 1 times negative 1, there's 3 negatives. Negative 1. So there's my 4 points. I can graph those 4 points. And I'm done. And then I just have to do the domain and range. Remember, domain is left to right. This one is weirder than a normal straight line because it's got a power, so it's a curve. So let's just graph it. Over 4 up 0, over 5 up 1, over 6 up 8, over 3 down 1. Oh yeah, this is one of these kind of graphs. I'll make a more exaggerated one. You guys have seen this graph before, haven't you? That's an x to the third graph. Remember that? It's kind of like a parabola on the top, and then it's like a flipped over parabola on the bottom. And so, what's the domain? Well, just ask yourself, if you kept going with this, would it go forever to the left? Yep. And forever to the right? Yep. And the range, does it go, how low does it go? Negative infinity. How high does it go? Help me, somebody. What's the last part of the range? Come on, just say it. Okay, fine, I'll call on somebody. Sophie, what's the range? Negative infinity to?
Negative infinity to positive.
You are correct. Positive infinity. Okay. Now, it's a little long. Even though I think you could absolutely handle it, I think the last problem is just going to be like busy work. So the last graph, the one that says y equals x to the third minus 1, you know that's just like the graph we just did, except it's moved down 1, right? Okay, so skip that one. Just skip the last graph and the domain and range of it. That'll save you a little time. Now, I bet you a lot of you could finish this in class, because I'm giving you 15 minutes right now. Be smart. Get it done. This counts. Goes in the grade. You bring it back tomorrow. Okay? And if you're struggling, please ask me for help. Maybe it's even on the basic 20 from yesterday and you're like, I still don't get this kind. Please ask me for help. I want to help you. That's all I got for you for today.